Experimental investigation of grit blasting parameters on alphacase removal of forged alloy part Ti6Al4V used in aviation industry. Abstract titanium and its alloys are attractive engineering materials used in aerospace industry because of their superior mechanical properties such as high specific strength and excellent corrosion resistance. Ti6Al4V alloy commonly used for manufacturing components in jet engines, such as fan blades, discs, wheels, and sections of the compressor where the maximum temperature is in the range of 300–450 degrees C. Titanium forged parts are heated above 900 degrees Celsius during forging, undergoes reduce roll, blocker, flattener, finisher, trimming etc. processes for producing final forging. During this process, when surface of forged part gets contact with oxygen from environment and producing oxide layer. This oxide layer is commonly known as alphacase. The alphacase layer has adverse effect on mechanical properties such as ductility, fracture toughness, and especially the fatigue life when an engine component is subjected to dynamic loading. The effect of grit blasting parameters on the alphacase removal and surface roughness of Ti6Al4V alloy was examined using the Taguchi designs of experiments and gray relational analysis. Keywords: alphacase, Taguchi design, gray relational analysis, surface roughness, Anova, grit blasting parameters. Introduction. During titanium forging, when heated parts are in contact with atmospheric oxygen, forms oxide layer on surface called as alphacase 1. Failure of titanium forged parts may be causes due to crack propagation on alphacase layer present on the surface. Etching is the process which removes the alphacase layer and avoids formation of cracks on the surface. This process involves use of hazardous chemicals like concentrated hydrofluoric acid, HF, and nitric, HNO3, acid with required proportion, which makes this process dangerous and required proper attention and safety measures to carry out process. Chemical etching also have adverse effect on part surface by introducing pitting and slash or intergranular corrosion and thus affects the fatigue strength too. Grit blasting can be used as alternate process for etching and can be used for removing alphacase layer by applying proper process parameters. Grit blasting process involves various process parameters like grit selection, exposure time, blasting pressure, blasting angle, distance of nozzle from the part surface. Hence it is required to develop scientific method to have both economic and damage-free grit blasting surface in case of titanium forged parts. Grit blast cleaning with abrasive media removes old coatings, rust, and other unwanted material from a surface, and creates an anchor pattern to allow new coatings to adhere better. Manufacturers who turn to grit blast cleaning as an environmentally responsible alternative to chemical stripping processes often realize substantial cost savings as well. 2. Experimental procedure. A. Material. Titanium forged flap track prolongations of material Ti6Al4V is used in experiment. The flap track is used in wings of Boeing 737 for aviation purpose. For experimental trails, the extracted prolongations are taken having dimensions: height 48 mm, width 77 mm, length 120 mm. The flap track material is given in table. B. Prolongation and bracket preparation. Bracket preparation is carried out for experimental work. Total 8 prolongation are used to make 16 trials, and for that it is required to mask half portion of prolongation. To mask that portion, bracket preparation is done having dimensions 200 mm x 200 mm x 100 mm as shown in figure 1a. Dia 16 mm and dia 13 mm rods are taken out from bracket, which will further used for locating of prolongation while experimental trails. See trail setup. Fig 2ae shows the trial setup for the experimentation of grit blasting of the flap track prolongation and bracket component. This experiment consists of air receiver tank, air dryer unit, hopper, and nozzle, L9 mm. For measuring alphacase hardness, Clemex micro hardness tester is used, and Mitutoyo surface roughness tester is used for checking surface roughness of grit blasted surface. D. Experimental parameters and levels. Grit mix, grit flow rate, intensity, grit blasting angle, grit velocity, distance between nozzle to workpiece, coverage area, grit blasting pressure and exposure time are the input parameters. Since some parameters such as velocity, intensity, and coverage are difficult to control, controllable influential parameters such as grit mix selection, grit blasting angle and exposure time factors were considered in the present investigation. Pilot experiments are carried among GH050 and GH025. Nominal size are in mm, from which GH050 gives promising results to remove maximum material. Other controllable factors levels are determined from literature base. These shot peening parameters along with their levels are shown in Table 2. 3. Design of experiment and Taguchi method. The Taguchi method is an optimization technique which is widely used in engineering analysis. This method reduces the no of experimental runs and cost associates with it. The Taguchi method uses a loss function to calculate the deviation between the experimental values and the desired values. The design of experiment, DO, was based on Taguchi design considering 4 factors each at 4 levels. In the present analysis, total number of runs equals L16 have been taken. The experimental results for alphacase depth, ACD, and surface roughness, RA, are depicted in Table 3 for 16 runs. Both alphacase depth is measured on transverse section of mounting and surface roughness were measured at surface of grit blasted prolongation of flap track as shown in Fig 1b. The effective use of Taguchi's orthogonal array approach for predicting the effects of individual process parameters on thickness of deposited layer in powder coating process. An orthogonal array approach and the signal-to-noise ratio have been used to understand the factor effects in powder coating of EN8 steel shaft. Experimental results are also provided to confirm the effectiveness of this approach for the body component. Traceability throughout the manufacturing process has the potential to change the way we approach the quality assurance and control issue. Thus, there is huge scope for data collection and analysis. This will assist to achieve the extremely ambitious goal of zero defect, i.e. the title of world-class manufacturer. 5. A/N Raut analysis. The analysis of variance is done to investigate which of the following process parameters has more influence on response value. Anova table can be generated from Minitab software or manual calculations. This is accomplished by separating the total variability of the S/N ratios, which is measured by the sum of squared deviations from the total mean of the S/N ratio, into contributions by each of the process parameters and the error. 5. The overall mean of S/N ratios can be calculated using the equations 1 to 3. In the Taguchi method, the term signal represents the desirable value, mean, for the output characteristic, and the term noise represents the undesirable value, SD, for the output characteristic. Therefore, the S/N ratio is the ratio of the mean to the standard deviation. Taguchi uses the S/N ratio to measure the quality characteristic deviating from the desired value. Loss function obtained from Taguchi analysis is further converted into a signal noise, S/N, ratio 3. Generally, there are 3 kinds of quality characteristics in the analysis of the S/N ratio, such as the higher the better, lower the better, and the nominal the best. 6. The objective of this project is to reduce alphacase depth and surface roughness. Therefore, smaller the better characteristic is used, shown in equation. Table 4 shows the experimental results for alphacase depth and the corresponding S/N ratios using the equations mentioned above. The response table and S/N response graph for alphacase depth are shown below. Regardless of the lower the better or the higher the better quality characteristic, the greater the S/N ratio corresponds to the smaller variance of the output characteristic around the desired value. 5. The manufacturing, assembly process, and powder coating process. There was a problem during assembly of parts of manual squeezer. By conducting experiments as per Taguchi's orthogonal array, following results have been obtained after the statistical analysis using descriptive method. The study showed influencing parameter in powder coating process is the spraying voltage. because it shows large variation in response value if its level is changed from 1 to 2. One can say that as voltage increases, the thickness of deposited layer increases. Also, it has no effect on outcome even if its level is changed from 1 to 2. The bake time and curing medium showed less variation when their levels are changed from 1 to 2. The amount of layer deposited on smooth part is less in comparison with that of rough part if all other parameter settings remain unchanged. 8. The dough trials conducted using Taguchi OASL4-23 experimental setup suggests optimum laser engraving DMC parameters is 8x8 mm2, DMC size, and 3 laser passes. The DMC code engraved by laser has performed successful scanning within required time constraint in the various manufacturing environment. So, it implements for the mass production applications. 9. B. Analysis of variance. Anova is a statistical method which is used to determine the interaction of individual for all the control factors in the test design. Anova is performed by using statistical software Minitab 14 to determine the significant process parameter. It helps in predicting the best combination of process parameters for optimal performance characteristics. For in this study, Anova was used to analyze the effects of grid blasting distance, grid blasting time, grid blasting angle and grid blasting pressure on alphacase removal and surface roughness. This analysis was carried out a 5% significance level and a 95% confidence level. The significance of control factors in Anova is determined by comparing the F value of each control factor. The last column of the table 6 shows the percentage value of each parameter contribution, which indicates the degree of influence on the process performance. According to table 6, the percent contributions of the A, B, C and D factors on the surface roughness were found to be 25.23%, 18.22%, 49.08%, and 5.08% respectively. Thus, the most important factor affecting the parameter on alphacase removal was blasting time, factor C, 49.08%. For conclusion, grid blast cleaning with abrasive media removes old coatings, rust, and other unwanted material from a surface, and creates an anchor pattern to allow new coatings to adhere better. Manufacturers who turn to grid blast cleaning as an environmentally responsible alternative to chemical stripping processes often realize substantial cost savings as well. Experimental work of removal of alphacase using grid blasting parameters based on Taguchi analysis has shown following important findings. Taguchi's robust orthogonal array design method is suitable to analyze the alphacase depth problem. The parameter design of the Taguchi method provides a simple, systematic, and efficient methodology for the optimization of the cutting parameters. Further S/N ratio analysis for alphacase depth predicts the optimum parameter combination for grid blasting parameters as level 3 for nozzle distance, level 1 of blasting angle, blasting pressure at level 4 and for blasting pressure at level 2 give maximum value of S/N ratio. Thus, Anova for data means of grid blasting with L16 DO shows that alphacase depth is most significantly affected by the blasting time is the most affecting factor on the alphacase depth with 49.08% followed by nozzle distance, blasting angle, and blasting pressure with 25.23%, 18.22% and 5.08% contribution respectively. Acknowledgement. We thanks to Production Engineering Department of VJTI, Mumbai for financial support for this project work and giving us the opportunity to conduct the project in industrial environment. Also, we thank to Mr. S. Ngawala, Senior Manager Aerospace Department of Bharat Forge Limited Pune for giving this opportunity to work in the company and providing me the necessary support.